virtual students. We're going to be recording here in a little bit, talking about circles. So just hang on. Another minute, Mira. Okay, let's get started here. There's a circle that I've drawn with a compass. Modules 15, 16, 17 is what we're going to discuss. A couple I can statements you're going to learn about the applications of circles, so you'll see it all over as we go through this. You're going to also know all the terms, definitions, circles. We're going to do more artwork with circles probably towards the end of this week, I think, is when we'll get to it. And all right, let's go. First term we want to talk about is a chord. C-H-O-R-D. Do not spell that with a K or forget the H. I mean, come on now. We gotta be better spellers than that. Anybody know what a chord measurement is? No? No. I mean, like in real life. Anybody know? It's a bundle of wood that can be burned. It's called a cord. A bundle of wood that can be burned. Okay, so what is a chord? It's basically just a segment. Okay, so in this circle, if I would connect an endpoint on the circle to another endpoint on a circle, that's a chord right there. And so we would label it just like we would a segment. So a chord is just a segment where its endpoints are on the circle. That's all a chord is. Okay? Do you think a diameter which goes through the center of the circle, do you think that is considered a chord? Yes, it is. So we'll call that CD. So CD is also a chord. Okay. All right, so we know what a chord is. Let's talk about central angle. We all know what an angle is, but the central tells us where it's located. Let's go down like this. Okay, so a central angle, let's call the center of the circle M. We'll go G, M, F. Okay, so this angle right here, angle G, M, F, is considered a central angle because its vertex is at the center of the circle. Rarely are we going to have a circle where we don't know where the center is. The center is usually denoted. It's not vague. So there's the center of the circle, M, and this is the central angle. Now, it intersects an arc. So watch this. Pretty little arc. I don't know about you, but this kind of looks like a piece of pizza. With yeah, maybe a watermelon's better. with circle seeds. I don't know if I'm hungry. Let's go to apple pie. Ooh. The green still isn't very good, though, is it? So, key lime pie. That's right, Owen. Oh, boy, am I hungry. But, you know, if you have an arc here, or you have an arc here, or you have an arc here, doesn't matter where the arc is. It does not. The central angle, the measure of this, let's say that it's 70 degrees. That's the exact same as the measure of the arc, 70 degrees. So the central angle is equal to its intercepted arc. Remember, no matter if the circle is this small or it's this big, they all have a total of 360 degrees. Does not matter how large or tiny the circle is. So that being said, it doesn't matter if the arc is here or here or here or here or here. They're all 70 degrees. Does that make sense? I can get my protractor out and measure it, but it's going to be the same. All of these would be 70 degrees. Does everyone see that? Okay, so the central angle, which in this case would be angle GMF, is congruent to its intercepted arc. So let's look at the arc. We're going to call that GF. Look how you denote an arc. You put a little arc over it. It's like a hat. It's like a cap. It's no cap for you, Evan. Yes, I'm very hip. I know what no cap is. Don't be rolling your eyes at me. You guys are embarrassed for me. I can see it. It's okay. I don't mind. You can laugh. You can laugh at me. I don't mind. Okay, so ArcGF has another name. ArcGF is called a minor arc. Now the arc. It's not ARK, Raven. That's Noah's. It's ARC. Minor arc. Less than 180 degrees. Okay, and so GF is considered. We have all kinds of arcs actually already on this picture. CB, right here, is considered a minor arc. The only thing you got to be careful of is that it does equal its central angle. So there's part of that picture. Okay. So CB is also a minor arc. Some interesting things with minor arc, like we've said before, we'll say that this is 50 degrees, that it's equal to its intercepted, or the angle at the center of the circle. Minor arc. Okay, let's do a major arc. A major arc just means that it's more than 180 degrees. All right, so in a case like this, here's a major arc. You got to follow. Let's use another color just because we can. We're going to start with B. We're going to work our way around. I'm going to stay on the circle because I've got good handwriting and good dexterity. There is a major arc. That means it's greater than 180 degrees. And in this case, it would be arc B. I could use either C or A, does not matter. I'll go A, D. Major arc, BAD. It's a bad arc. We're on a roll today, Abbott. Okay, major arc. Questions? Notice that I'm using 3 letters. Okay, because if I just call this BD, how could you make sure that certain that it's not just this one? See what I mean? So the middle letter gives you kind of the direction that the arc is talking about. It's going that way. Okay. It also could be labeled, and you guys dab each other up. Okay, we got one more. Oh, I love what I do. Semicircle. All right, what's that look like? Well, that just means you got a diameter. It goes right there, halfway through. 180 degrees in that, in the semicircle. We usually use 3 letters to denote a semicircle. A, B, C. And it's equal to 180 degrees. In our picture, we also have a semicircle already drawn. There's our diameter. So we got 2 semicircles. Now, a couple things that's interesting, I think, about a semicircle is if I do an inscribed angle, which I haven't talked about yet, but we will. If I do an inscribed angle in a semicircle, it is 90 degrees. Always. So what is an inscribed angle? I know I'm kind of jumping around, but an inscribed angle is an angle whose vertex is on the circle. So it's different than a central angle because that's at the center of the circle. So an inscribed angle is on the circle. So this is an example right here that I'm outlining right here of an inscribed angle. Okay? let's put a letter on this. What letter haven't I used? Let's use, I don't know, let's go N. Okay, and so we have arc C and D we know is equal to 180 degrees. Okay, but angle C and D is only equal to 90. That is always the case. But the measure of the inscribed angle is half of its intercepted arc. Always, always, always. Okay? So back to this picture. See, remember when this one was 50? Let's say that I draw in that as an inscribed angle. All right, I know we're getting busy here. Gotta pay attention. So we'll put that there. Now let's put that as an O. And so now I have an inscribed angle of COB, C-O-B. It's half of its intercepted arc. And so the measure of angle COB is 25 degrees. Has to be. Because this one's 50. Getting the tie-in now? And so if we knew that this was 25 first, then we would know that that's 50. Has to be. Okay? So it can get confusing. You got to know the difference between a central angle and an inscribed angle. If it's inscribed in a semicircle, I've already told you this, it's 90 degrees. Does not matter where. It could be like this. Does not matter. It's 90 degrees because it's in a semicircle. Okay, questions? Okay, so we talked about a minor arc we have, but we talked about a major arc we have. All right, well, I think we got one more thing to talk about, and that's what we call an arc addition postulate. Remember, we don't prove postulates to be true. We just accept them to be true. Very similar to one of the first concepts we ever talked about in geometry, which was the segment addition postulate, which says this, that AB plus BC is equal to AC. If I take this segment plus this segment, 3 plus 5, I know that the whole length is 8. Okay. Same idea in the arc addition postulate. Let me put a new circle here. You're going to get very good at drawing circles freehand. Okay, so if I have A here, we'll go B here, and we'll go C here. If I look at the arcs AB, by the way, these are called adjacent because they're right next to each other. Very similar to adjacent angles. These are adjacent arcs. So if I do that, I know that arc AB with a cute little cap on top plus BC with another little cap on top. That's equal to arc. Now we usually, when we do that, we use 3 letters, again, just so that we're clear we're not going this way. Okay? And so I'm taking this arc plus this arc, and it's equal to the entire thing. Do I know the measure? Well, I could. I mean, I could say, let's say that that's 50, and, this is, 110. That means from here to here is 160. Okay, so I can do, hopefully you can see that there's going to be problems that we could generate algebra type of equations. Arc addition postulate. Any questions on that? I think we hit everything so far. Yeah, the inscribed angle. Tomorrow we will look at some of these definitions in relation to problems and then how we can solve them. Okay? That's it. That's it for the day.